So last week, at the end of what was kind of a crummy day, actually, I was in bed with my phone plugged in, just Googling random things, kind of stream of consciousness, I guess, instead of reading a book. And I saw an image for something that I knew existed and had seen in early drawings, but had never seen a modern photograph of, and had certainly never seen in person. And it was an eBay listing, which I don't think I ever clicked buy it now on something so fast in my life. Despite the high price, which was evidence that the seller knew they had something special, because they certainly had no basis for comparison. You never get a good deal when you know that you're buying something no matter how much it costs. That's never a very good negotiating position to be in. But what arrived I'm happy to see it has been well packed. So this is an original Spencer Vacometer. And it's something that if you've really watched my other videos carefully, you might remember me making reference to this. I never really had any expectation of finding one, but I wasn't aware that these actually had a badge on them that said what they are. So that makes it easier. I thought I was doomed to a lifetime of searching eBay for steampunk vacuum gauge tester apparatus, and no, this came up as a Spencer Vacometer here. And this will be from sometime between 1912 and 1918. And I can tell you that because 1912 was when Ira Spencer filed the trademark for the name Vacometer, and 1913 was when he filed the patent on the actual apparatus itself. But 1918 was when Spencer Turbine Cleaner Company and the Organ Power Company merged to become the Spencer Turbine Company. So the fact that this says it's a Spencer Turbine Cleaner Company means that it's pre-1918. So what this is it's the great granddaddy of the testing Y for modern central vac systems, which is a VacuFlow product, which has an orifice and a provision to attach a vacuum gauge. Well, this one has a vacuum gauge which is reading in inches of mercury and a selectable orifice size. So by turning this, you can measure the vacuum at the hose end at different orifices. And you connect your vacuum hose there. So this was in upstate New York, and the description said it came out of an estate. And I don't know if the estate it came out of was just a tool nut and bought this. I'm certain at this point that this was not from the original owner. Yeah, we can make that assumption safely. But I'm just delighted to have this, because I even contemplated how I could maybe have one made, the casting and the everything, and attach my own gauge to a threaded tapping at the top. But here we are. So I have some literature on this Vacometer, which was made up through, this is a 1949 catalog. This was made into the 50s and beyond. So in this catalog, it is shown with, in place of the dial type gauge here, it's shown connected to a YouTube mercury column, which would give an extremely accurate measurement, but it wouldn't be as portable. And as you can see here, every Spencer central cleaning system is guaranteed to supply a given vacuum at the end of a 50-foot length of hose under certain specified conditions. To accurately determine whether this system meets the guarantee, the globe-type vacometer has been found to indicate the correct vacuum accurately. The difficulty with most types of vacuum meters is that they show induced readings on the gauge, with the result that the system apparently delivers much more vacuum than is actually the case. So if you take a water lift gauge and you stick it on a vacuum hose, you're getting the max water lift, not the water lift with air moving. And those can be two very different numbers, as anybody in the vacuum field would know. And so this is made to measure with a certain quantity of air flowing. It has been found through years of experience that to do rapid and thorough bare floor sweeping, there must be maintained at the end of the vacuum hose not less than 2 inches of vacuum. Now remember, that's mercury column, while a 7/8 inch round sharp-edged orifice in a 1/8 inch plate is open. To do rapid and thorough carpet cleaning, not less than 3 inches of vacuum must be maintained with a similarly constructed 5/8 inch orifice. They calculated that the 7/8 orifice was equivalent to, in resistance, to a floor brush down on the floor, and the 5/8 orifice was equivalent in resistance to a I think it's a 12 inch or 14 inch carpet tool down on the carpet. And you can see here we have the conversion, inches of mercury, inches of water, and pounds per square inch, which we usually don't use in vacuum. But you can see that 2 inches of mercury is equivalent to a little over 25 inches of water, and 3 inches of mercury is equivalent to a little over 40 inches of water. And so our measurements will be down here, and this gauge reads full vacuum up to 30 inches of mercury. So we would never use this. Even in your really high vacuum systems, it really didn't get above 10 or 15, because 10 inches of mercury is over 130 inches of water lift. So this gauge really only needed to be that big, but they used an off-the-shelf mercury gauge. We can also refer to the vacometer in this book, which is a 1920s Spencer catalog, and it's towards the end here. This has, I should just go through this whole thing, but that'll be a different video. This has some beautiful drawings of the machines available at that time. Okay, there's the vacometer. So there we see our drawing in the flesh, in the aluminum. Specifying a given vacuum and volume at the tool while in use has proven unsuccessful. First, because an expert operator can so use the tool as to make the reading unreliable. Second, because air volume measurements are unreliable unless taken with a higher degree of refinement than is practicable under the conditions found on vacuum cleaner jobs. So an anemometer would be difficult to impossible to bring in, set up accurately, and at least at that time, and make the conversions between feet per minute into cubic feet per minute. So you need something that you can just take in, stick on the end of the hose, and say, here you go, it does the job. And this again refers to those same 2-inch and 3-inch standards. This has been termed heavy duty, and your smaller systems, like for a home, it wasn't as important. They wanted to have 1 inch for bare floors and 1.5 inch for carpets, and that's termed light duty. Finally, we have this passage from Vacuum Cleaning Systems, the Bible of early built-in vacuum technology from the 1914, I think this book was written. The most satisfactory method of testing that has been devised is the use of an orifice of proper size fixed to the hose end and measure the vacuum just inside this orifice. Convenient form of testing appliance based on the orifice test is the Vacometer, manufactured by the Spencer Turbine Cleaner Company. A spherical aluminum casting with a 1-inch diameter hole on the equatorial circle, a vacuum gauge being attached to one polar extremity, the other being attached to the end of the hose. A ring having a slip fit is placed around the equatorial circle, in which openings varying from 1/2 inch to 7/8 inch diameter are drilled. Experiments with this instrument in connection with a pitot tube show that a 1/2 inch diameter orifice is equivalent to a type A carpet renovator, narrow slot, a 5/8 orifice to a type F renovator, wide slot, which was what Spencer always used because a Spencer machine had higher airflow, so you could use a wider tool, and a 7/8 inch orifice to a bare floor renovator. With instruments of this type equal in number to the capacity of the plant in sweepers attached to the ends of the cleaning hose, it is possible to obtain uniform conditions equal to the average results that will be obtained in actual practice with renovators attached to the hose without the possibility of expert manipulation of the renovators affecting the results. And they have specifications for different types of plants. For example, the last one here, class 4, that was for a bare floor only system, it would be a 2-ec basically. 7/8 orifice, 1-inch vacuum, all hose lines, maximum length. You wouldn't bother using a device like this to test a residential system. This is for a commercial multi-user system where a specification has been issued, number of operators, etc. And the contract was awarded on the basis that the system could actually meet that specification. Because obviously it's easy to underbid and lie about the performance of the system, and it's also easy to put in a plant that's way too big and have it be much more costly than it needed to be. So to guarantee the most efficient type of installation that would still meet the requirement while being cost effective, you had to be able to measure this. So this would be ideally, you were talking about multiple ones of these. So on a 6 operator system, you would have 6 hoses plugged in, each with a vacometer attached. And in fact, this text goes into 1/2 the inlets, 1/2 inch orifice, 4.5 inch mercury at one orifice attached to the end of the longest hose desired to use in practice. The remaining 1/2 inch outlets on shorter hose length. The other half of inlets to have 7/8 inch orifices open at the same time, with longest hose on 1/4 of total inlets and shortest on the balance. So they were trying to come up with these different scenarios to make sure that no matter who was vacuuming what with what length hose, they'd all have an acceptable level of performance. And so that's that. An original Spencer vacometer. And this goes from 7/8, so this is your bare floor orifice. And they had some intermediate ones that I'm not sure what you'd use them for, because the only ones they ever make reference to are 7/8, 5/8, and 1/2 inch, which was the case of your smallest carpet tools. So this can measure those and several sizes in between. And in an upcoming video, we will test this out. We will measure some performance of some Spencer systems from the time that this was made. As always, thank you for watching.